In this video, we're going over lesson 2.5 absolute value equations. What we're going to do is the front side is going to be the notes. Make sure you're following along with me, filling out the front side, and then the back side is going to be the assignment. Question number 1, solve each equation. So when you do have an absolute value equation, we have to remember when you take the absolute value of anything, it always gives you a positive number. For example, if I take the absolute value of the number 1, it's just 1. If I take the absolute value of a negative 1, it is also 1. A lot of times we use the absolute value when we're talking about distance. Okay, so with that being understood, question number 1, I can think about x being 9 or a negative 9, and both, when I take the absolute value of those, I'll get a positive 9. So a lot of times what we do when we're solving absolute value equations is we set up two cases. So case 1, when what's inside is equal to a positive 9, and case 2, when what's inside is equal to a negative 9. All right, and then from there we would solve it. But in this case, it's already solved for us because x is already by itself. So if I was to take the absolute value of 9, I would get 9, so that's why 9 is a solution. And if I take the absolute value of negative 9, I also get positive 9, and that's why negative 9 is a solution. With absolute values, a lot of times we will have two solutions. It's possible to have one solution, two solution, or no solution. All right, question 1's complete. Let's take a look at question 2. What I'd like you guys to do is pause the video and see if you can write down both answers and then resume once you have those answers. All right, our answers should be k is equal to 8, k is equal to negative 8. Because remember, when you take the absolute value of anything, it's always positive. Absolute value of 8 is positive 8. Absolute value of negative 8 is also positive 8. All right, let's see what happens when we have other operations with our absolute value. Question number 3, 7 times the absolute value of n is equal to 28. So whenever we set up our two cases like we did in questions 1 and 2, you only do that when the absolute value is by itself. So right now, we have a 7 in front of the absolute value, so we're not going to set up our two cases quite yet. We need to get rid of that 7. And since the 7 is being multiplied to the absolute value, we're going to have to divide both sides by 7 before we can set up our two cases. Okay, so we're going to divide both sides by 7, and now we're left with the absolute value of n is equal to 4. Now that the absolute value is by itself, let's set up our two cases. When n is equal to 4, when n is equal to negative 4. So n could be 4 or negative 4, and it would work for this problem. Okay, let's take a look at number 4. Let's do the same thing. Let's have you pause the video, give it a try, and then resume when you're ready to see my answer. Hopefully you've attempted the problem. On question 4, the absolute value of v is not isolated, so I'm going to start by subtracting the 8 before I set up my two cases. Absolute value of v is equal to 5. Now that the absolute value is isolated, I'm going to set up my two cases. V is equal to 5, and v is equal to negative 5. And that's the two solutions for number 4. All right, number 5. Notice that it's different than number 4 because the absolute value technically is already isolated. Everything's inside the absolute value that's on the left. Where number 4, we had things outside of it. Okay, so what that means is we can actually set up our two cases right now. Whatever's the absolute value of can equal 11. So v minus 9 can equal 11. And that would be a solution to this problem. Or v minus 9 could equal negative 11. And if you're asking, well, why is that the case? Because remember, whatever's inside this v minus 9, if it's negative 11, after I take the absolute value of it, it'll give me positive 11. Okay, and that's why I'm setting up this case. That case represents what we just talked about. Okay, now that I have both cases set up, I'm going to solve them. Now the other ones, I didn't have to do anything after I set up my cases. The variable was by itself. Okay, but these, you can see I'm going to have to move the 9 over. So I'm going to add 9 on my first case. These eliminate, and I get v is equal to 11 plus 9, which is 20. So v could be 20. That should be a solution to this absolute value. Or if I add 9 on the second case, I get v is equal to negative 11 plus 9, which is negative 2. Both of those should be solutions. I'm going to check it. If I plug a 20 in, 20 minus 9 is 11, and the absolute value of 11 is 11. If I plug in a negative 2, negative 2 minus 9 is negative 11, and the absolute value of negative 11 is also positive 11. All right, let's look at number 6. Number 6 is set up the same way as number 5. Pause the video and see if you can set up your two cases. And if you're comfortable, go ahead and try to solve it, and then resume when you need to. All right, as I just mentioned, the absolute value here is by itself. Everything on the left is in the absolute value. P is not by itself, but that's not what I'm looking at right now. I'm making sure everything's inside the absolute value. Just like we had with number 5, everything was inside the absolute value on the left. Going back to number 4, that wasn't the case. We had an 8, so we had to move the 8. Going back to number 3, we had to move the 7. Okay, so everything's inside on number 6. So I'm going to set up my two cases. What's inside, which is negative 1 plus p, that could equal positive 2, and that would be one of my solutions. Or what's inside can equal negative 2, and that'll also be a solution to this problem. Okay, I'm going to solve the one on the left. Add 1 to both sides. When I add 1 to 2, I get 3. So p equals 3. That's the solution. The second case, I'm adding 1. Add 1 to negative 2, and I get p is equal to negative 1. So these are the two solutions to that absolute value equation. Okay, so just a reminder, you want the absolute value by itself, and then you set it equal to the positive of what's on the other side and the negative of what's on the other side. So that's why I got 2 and negative 2. All right, let's take a look at number 7. So first we have to ask ourselves, is the absolute value by itself? And the answer is no. We have this 4 out in front, so we have to get rid of that 4. Okay, now since 4 is being multiplied to the absolute value, I'm going to have to divide. Now a common mistake is some students think that the absolute value is just like a parenthesis and they try to multiply that 4 in. You cannot do that. Whatever is outside the absolute value must remain outside. It's not like a parenthesis. Okay, so let's go ahead and divide by 4 to get rid of that 4. Now I have the absolute value of 6v is equal to 72 divided by 4 is 18. So absolute value of 6v is equal to 18. Now that the absolute value is by itself, everything over here is just inside. Now I can set up my two cases. What's inside, which is the 6v, could equal positive 18, or 6v could equal negative 18. Both of those would be solutions to this equation. So I need to divide by 6. 18 divided by 6 is 3. And when I divide negative 18 by 6, I get negative 3. So 3 and negative 3 are the solutions here. So do keep track. If you look at all of our answers, they're not always just the opposite. Okay, so I know with question 1, question 1 we got 9 and -9. Question 2, we got 8 and -8. Question 3, we got 4 and -4. Question 5, though, we had 20 and -2. So don't always just think, if you get one of them, just switch the sign for the other answer. It doesn't always work that way. All right, let's look at question 8. See if you can try this one first and then resume the video when you're ready to check my work. All right, so we have to start by moving the 3 because the absolute value is not by itself. So I'm going to subtract 3. And now I have the absolute value of 7n is equal to 38 minus 3, which is 35. Now that I have the absolute value isolated, or the absolute values by itself on the left, I'm going to set up my two cases. -7n equals 35, or when -7n is equal to -35. Both of those would be solutions to this equation. Divide by -7. We're going to get -5 here, and divide by -7 and get +5 on the other side. Those are the two solutions to that equation. All right, hopefully you're finding these videos helpful. This is the 2.5 lesson. What you need to do is finish the back, and that's going to be all of Friday's lesson. Thanks for watching.